Hello my dear students, I welcome all to the next session of Exploring Physics. So what is the lesson we are studying? We are studying about light. In the last class, what are the things we studied? We studied about refraction, refractive index, rules of refraction. This is really an interesting topic. And in today's class also, we are going to deal with the interesting concept, that is effects of refraction. You will be observing these effects of refraction in your daily life also. So, I will be asking simple questions. So, you will be learning along with me. Okay? So, shall we start learning? Yes. The coin placed at the bottom of the water, it will appear to be raised. Have you noticed it? Why this happen? My next question is, have you ever visited the swimming pool? The swimming pool will look shallower than it really is. You will not be able to feel the actual depth of the swimming pool. Why this happens? The print on a sheet of paper appears to be raised through the glass slab. When you are viewing it through the glass slab, it appears to be raised. Why such things are happening? We know the answer. Yes, it's due to the refraction. But we have to understand it clearly. Right? Now we are going to do that. Yes. Bending of light from one medium to another makes our eyes to perceive the displaced image of an object. So how we are seeing the displaced image? When the coin is placed at the bottom of the water, the light has to travel from the water medium to the air medium because we are viewing outside and we are viewing obliquely. So, the light traveling from water medium to air medium, it has to bend. Right? So, due to the refraction, we are able to see the raised appearance of the coin. Similarly, the pool of water seems shallower. So, in this image, the fish is actually at the bottom, but we will be able to see it in a raised position. It is also due to the refraction. The light has to travel from the water medium to the air medium. So it results in the displaced image. Here also the light has to travel from glass medium to the air medium. So we are able to see the displaced image of the print. So we have witnessed how the effects of refraction is playing the role in our daily life. Now we are going to see about the refraction of light through the rectangular glass slab. What is rectangular glass slab? Yes, it is just made up of glass and it is rectangular in shape. That's it. How many times the ray will be refracted when it passes through the glass slab? Do you know that? Can you imagine? It will be refracted 2 times. In this picture, can you see it? There are 2 bendings in that glass slab. When the light rays traveling through air enters the glass slab, they get refracted and bend towards the normal. So, there is one refraction. Now, the direction of refracted ray changes again when it comes out of the glass slab into the air. Since the ray of light is traveling from denser medium to rarer medium, it bends away from the normal. So can you see in this picture, when the light is traveling from air medium to the glass medium, it is bending towards the normal, but when the light is coming out, it is bending away from the normal. When the light falls perpendicularly or normally on the surface of the glass slab, what will happen? Will the refraction happen? No. There will be no bending of light. We have already studied it many times and also in the rules of refraction. There is no bending of light on entering the glass slab or coming out of it. In this case, angle of incidence and angle of refraction is 0. Now we are going to watch an YouTube activity video to learn the refraction of light through the glass slab clearly.
Hi students, today's experiment, refraction of light through glass slab. In this experiment, to identify the images through glass slab and to understand the lateral shift. Materials required: glass slab, protractor, ruler, paper pins, cardboard pins and pencil.
Arrange an A4 sheet on a drawing board using cardboard pins. Place the glass slab in the middle of the sheet and draw the outline ABCD. Draw a perpendicular line at point O to line AB. Using protractor, draw the incident ray at O and angle 30 degrees to the perpendicular line. And extend incident ray using dotted line. Mark the points PQ on incident ray using drawing pins. Place the glass slab on rectangle ABCD and view the images of pins PQ through side CD. And now you can see clearly the two pins are at same line. Viewing the images of pins PQ, fix another pin R in the same line. And here it is very clear that the three pins are at same line. In the same way, fix another pin S in the same line. Remove the glass slab and drawing pins. Connect the points R, S from CD side to draw the emergent ray. Let us draw the refractive ray to ABCD. And I am doing it, children. You can see it clearly. Draw a perpendicular to the emergent ray on CD. Measure the angle of refraction using protractor. We can find it as 20 degrees. Measure the perpendicular distance between emergent ray and incident ray. We call it as lateral shift.
Example which I have taken from the book. Here the ray is passing from A and it strikes the glass slab at point B. So AB is the incident ray initially. What is the angle of incidence here? It is I. When it is striking the B, there is refraction, there is bending happening. The angle of refraction at that point B is R. Again, the ray is traveling through the glass and when it is coming out, it has to encounter the different medium. So, again there is one angle of incidence and another angle of refraction. So, at point C, we call that angle of incidence as I dash. And at point C, we are getting another refraction. We call that angle as R dash. R dash is called the angle of emergence. And that final ray we are getting, CD, is the emergent ray. You will notice that angle I is equal to angle R dash and angle R is equal to angle I dash. Angle R dash is called the angle of emergence. CD is the emergent ray because at last it is coming out of the glass slab. So it is called as emergent ray. Thus, the incident and the emergent rays are parallel. Can you see that? Yes. We can then conclude that when a ray of light passes through a rectangular slab of glass, it emerges parallel to and shifted from its original path. The refraction through prism. Earlier, we saw about refraction by a glass slab. Let's see whether the refraction are similar or differing. This is called prism. What does it look like? What is the material it is made up of? Yes, it is made up of glass. Prism is a piece of glass formed by 3 rectangular faces. Zoom in and see there will be 3 rectangular faces and there will be 2 triangular faces. So, there are 2 triangular surfaces and 3 rectangular surfaces. Let's say M1 and M2, those rectangular surfaces, are the 2 faces of prism where the refraction of light takes place. They are inclined to each other at an angle. Can you see? So, that is called angle of prism. Therefore, angle AOC is the angle of prism here. For simplicity, we used to draw the ray diagram like a triangle. Okay, then only it will be easy for us to show the ray diagram. Okay, so here angle AOC is the angle of prism. So, what is the refracting surfaces? Rectangular faces or the refracting surfaces. Okay.
Let us now trace the path of light through a prism. Place a prism on a white sheet of paper with a triangular face on the sheet and trace its boundary A, B, C. Fix 2 pins T and S on one side. Place the prism on the boundary A, B, C. Looking through the other side, fix 2 more pins Q and R in such a way that all the 4 pins appear to be in the same line. Remove the pins and mark their positions. Join TS and RQ and extend them to meet the faces of the prism at P and O respectively. Join PO. TP represents the incident ray. PO represents the refracted ray. And OR represents the emergent ray which is bent towards the base. Let PN and ON be the normal at the points P and O respectively. And let I be the angle of incidence and R the angle of refraction. If the incident ray TP is extended forward and the emergent ray RO backwards, they meet at M, forming the angle OML. Measure the angle OML. This angle is called the angle of deviation. Angle of deviation is the angle through which an incident ray deviates. Repeat this.
How many times the light ray bends when it falls on the prism? It bends 2 times. When a ray of light enters the glass prism, it gets deviated 2 times. First, when it enters the glass prism, and second, when it comes out of the prism. Does the emergent ray come out parallelly to the incident ray in prism also? Because we have learnt that in glass slab, when the light is passing through it, the incident ray and the emergent ray will be parallel. But it is not the case in prism. The rays will not be parallel. It is deviated from its original path by a certain angle. And it will move towards the base. The emergent ray, it will move towards the base. Are you able to name the terms related to the refraction? Here, where is the incident ray? PE is the incident ray. Where is the refracted ray? EF is the refracted ray. FS is the emergent ray. The ray which is coming out through the prism, that is the emergent ray. A is representing the angle of prism and angle I is representing the angle of incidence, angle R is representing the angle of refraction, angle E angle of emergence, angle D is angle of deviation. Angle D is called the angle of deviation. It measures the deviation of the emergent ray from the incident ray. If you measure the angle of incidence, angle of emergence, angle of prism and the angle of deviation, you will find that sum of the angle of incidence and angle of emergence will be equal to sum of the angle of prism and angle of deviation. This is true for all the prism when the light is being traveled through it. I think you may have all studied about the layers of the atmosphere. What are the layers? Troposphere, stratosphere, mesosphere, thermosphere, exosphere are the layers of the atmosphere. These layers will not be very similar. They will have the change in optical density. Each layer will have their own optical density. Actually, within one layer also there will be changing optical density and hence changing refractive index of air. So what do you think when the light is falling on these layers, what will happen? The light will be refracted many times. The light will be bending at many points of these layers. So this results in refraction. So what we are going to study now? We are going to study about atmospheric refraction. These layers are not fixed one. They keep changing due to many reasons. For example, during the day, the air near the earth gets heated, so its density decreases. At night, on the other hand, the earth cools as does the air in contact with it, so the density of the air close to the earth increases. So when the air layer is cooler, it will act as a optically denser medium. When the air layer is warmer, it will act as a optically rarer medium. So this is the basic of atmospheric refraction. This results in so many beautiful phenomenon like twinkling of stars. So here, when the light is falling on the layers, they will be bent at so many points. That's why we are able to see the twinkling of stars. We will see this clearly in the upcoming slides. So what is atmospheric refraction? When the refraction of light takes place during the Earth's atmosphere, it is called atmospheric refraction. One thing, we are able to see the sunrise earlier by 2 minutes, and we are able to perceive the sunset as delayed one. We are going to analyze the reason for it using an YouTube video. So keep watching.
Now this is very interesting. You get to see the sunrise before the sun actually rises. You know what happens? Earth's atmosphere has different layers. And also, the optical densities of these layers decreases as you move away from the Earth's surface. That is with increasing height. So, what happens is, just before sunrise, before the sun reaches the horizon, the sunlight enters obliquely into the atmosphere. It gets refracted through the atmospheric layers. Now this refraction causes the light rays to bend. So the sunlight actually reaches the Earth's surface in a curved path. Now, what happens from the point of view of an observer? Following the path of the light rays entering the eyes, the observer actually sees the sun slightly above its actual position. And as a result of that, he sees the sun about 2 minutes before the sun actually rises.
As we saw in the YouTube video, when the rays of the sun enter the atmosphere from the space, that is vacuum, they bend towards the normal, since air is optically denser than vacuum. We have already studied that when the light is passing from optically rarer to the optically denser medium, the emergent ray, that is refracted ray, it will bend towards the normal. So that's what is happening here. And when these rays enter our eyes, it appears to us that the sun is above the horizon. Similarly, at sunset, we continue to see the sun 2 minutes after it has gone below the horizon. Thus, the day becomes longer by about 4 minutes. Interesting question is, why do stars twinkle? This is also the another effect of atmospheric refraction. The light from a star is refracted by various layers of the atmosphere before it enters our eyes. The densities of these layers, they keep changing. We know this already, no? Depending upon the day and night, the densities of these layers will be changing. And it is also because of atmospheric disturbances. So the amount by which the rays bend keeps changing and the position of the star appears to change. This is what makes a star twinkle. Heavenly bodies that are closer to us, such as moon and planets, do not twinkle. This is because they look much bigger, so our eyes can make adjustments for the apparent shifts in their positions because of atmospheric refraction. Now we are going to see a small YouTube video explaining about the twinkling of stars. It will be interesting.
Topic: atmospheric refraction. Why do stars twinkle?
Because they blink their eyes.
Nah. The twinkling of stars is due to atmospheric refraction. Atmospheric refraction is the bending of light caused by the Earth's atmosphere.
I thought atmospheric refraction is the bending of my body due to Earth's atmosphere.
Oh, please listen. Earth's atmosphere is changing continuously. When the light of a star travels through space towards us, the continuously changing Earth's atmosphere refracts or bends the light by different amounts and in different directions every moment. When the atmosphere refracts more starlight towards us, the star appears bright, and when the atmosphere refracts less starlight, the star appears dim. In this way, the amount of starlight reaching our eyes increases and decreases, causing the star to appear twinkling.
In today's class, we have studied about effects of refraction. In that, we have studied about refraction through rectangular glass slab, refraction through prism, atmospheric refraction. In atmospheric refraction, what did we study? We studied how the stars are twinkling and why the early sunrising and late sunset are happening. Right? So, for the follow-up work, you have to draw the ray diagram to show the refraction of light passing through the rectangular glass slab. Second thing, draw the ray diagram to show the refraction of light passing through the prism. Third question is, why does the sun seen before the sunrise and after the sunset? Explain with the diagram. So these are the follow-up work for today's class. Do submit your answers in the GCR. In the GCR, I will be posting the questions. For the last week, I didn't post the question, so I will be posting the question for the last week as well as for this week. You can submit your answers in the GCR. Thank you, students. Thank you for listening. Keep exploring physics and learning physics. Take care. Bye-bye.